Hello everyone, this is Sarvachan Verma and currently I am working as a assistant professor at Ajay Kumargar Engineering College, Ghaziabad in IT department, and in the video lecture series today I am going to different searching algorithm and searching methods are available in artificial intelligence system. Now you will see here, if we're talking about searching methods and algorithm, so in AI probably we see two type of searching. First one is uninformed search and second one is informed or heuristic search. The names both are same. Okay. Now uninformed search. Okay. Uninformed search means a search algorithm do not have additional information about state or search space other than how to traverse the tree, so it is also called a blind search. We can, the different second name of uninformed search is blind search because they do not have additional information about states and search space. Okay. There are following types of uninformed search algorithms are available in AI. We will study one by one and further. First one is breadth first search, second is depth first search, depth limited search, iterative depending depth first search, and finally fourth one is bidirectional search. Okay. Now, if we are talking about breadth first search, basically breadth first search is the most common search strategy for traversing a tree or graph. First one thing, okay. Basically this algorithm search breadth wise in a tree or graph, so that we can say it is a, we can always call the name of this breadth first search. Third one is BFS algorithm starts searching from the root node of the tree and expand all successor node at the current level before moving to the next level. Okay, I will explain it. And third one is the BFS algorithm is always example of a journal graph search algorithm. The most important thing is that the BFS use Q data structure, or if we are talking about Q data structure, Q is a linear data structure which is depends on first in first out operation. Now inside this figure you will see here, this is my root node. After that this root node have two successor A and B, two branches. They move first this, then move to the next. You will see here. Okay, these are the levels. So you will see, if we are going to traverse this tree, you will see here first you go S to A to B to C, and this is the wider region because it moving to the next level. First it traverses the all the true and all the branches of a particular graph or tree. Second one is depth first search. Basically depth first search is a recursive algorithm. Recursive means when they are work repeatedly on different values. We can say recursive is a functions in computer science and IT branch. A function, we can say it is a recursive function if it call again and again. Okay. Basically DFS is a recursive algorithm for traversing a tree or graph data structure. Second thing, why we can say it is a DFS, because it start from the root node and follow each path to its greatest depth node before moving to the next part. And third one is DFS use a stack data structure for its implementation. You will see here inside this, this is the scenario of DFS. First it will move to next level, then move to next level, then move to next level. Then this is the procedure. Okay, because it will use which data structure? It will use a stack data structure. This is called the stack data structure. Stack data structure depends on last in, first out. Last in, first out. Third search algorithm is depth limited search. Depth limited search means a depth limited search algorithm is similar to DFS with a predetermined limit. It means this type of searching algorithm has predefined limit of number of labels. At what level we have to search. Depth limited search can solve the drawback of the infinite path in the DFS. In this algorithm, the node at the depth limit will treat as it has no successor nodes further. If we define the depth that we have to search at the level 2, this is the final. The search is not go beyond on a particular level. We will see here inside this problem. This is our one tree. Below is the graph. We will traverse same as DFS. We use the stack data structure S1 to record the node we are explored. Suppose the source node is A. Suppose I am going to start the traversing from this end. Okay. Now S1 is treated as a stack. You will see here at the first the only reachable node is A. So push it into S1. Okay. And mark it as visited, and we are at the label 0. Okay. Now inside stack I push visited node A. After exploring A, now there are 3 nodes reachable from A. You will see here first one is B, C and D from root node A. Suppose we pick node B to explore first, push B into the stack S1 and mark it as visited, and we are at the current level 1. So this is our stack position. At the top of the element of stack is A. Okay. Now since current level is already the max depth L, because I have already defined that level is 1. Node B will treat as having no successor because of the searching is already go behind to the maximum depth level. So there is nothing reachable. Pop B from S1 and current level, again we will move to the 0. Okay. Explore the again. There are 2 unvisited nodes C and D that are reachable. Suppose we pick node C to explore first. Push C into the stack S1 and mark it as visited. We are again current level at 1. Okay. So this is the current positions of A. Sorry, this is the A, this is the C. Okay. So since current level is already the max depth L, node C will be treated as having no successor. So there is nothing reachable. Pop C from the S1 and current level again we will at 0. Similarly, after that again I will explore D and visit it. Okay, this is not our goal state and we will reach at our maximum depth. We have already defined. So explore D and find no new node is reachable. Pop D from S1 and current level it is the 0. Explore again, no new reachable node. Pop A from S1. S1 is empty. We have finished our search. So inside this you will see here we define the depth of a particular searching. If our goal state is find at particular area of a particular label, then search is successful, otherwise search is unsuccessful. But if limited is defined, in that case it will not move to the next level. Okay. Iterative depending search. Because this searching algorithm is used to overcome the problem of previous algorithm. Which is the previous algorithm? Depth limited search. Iterative deep search algorithm is used to remove the limitations and overcome the limitations of previous algorithm. Iterative depending search is a journal strategy often used in a combination with depth limited search that find the best depth limited. It does this by gradually increasing the limit. First, it set as a final label is 0. If goal state is fine, then search is successful and search is finished. If goal state is not fine, then gradually increase to the next level, then gradually increase to the next level until a goal is found. Okay, you will see here inside this picture. Suppose I want to find out, this is my goal state. Suppose this is my goal state. Initially I have defined label is 0. Okay, I am going to goal is node state is A, gradually increase L1, visit all the nodes, no found. Again फिर gradually increase the 2, visit every node from the root node, we find the goal state. Okay, so this is very good algorithm, and this is inside this. Basically gradually हम लोग we can increase the particular depth at a particular moment. Okay, this is the last search. This is called the bidirectional search. So basically bidirectional search algorithm runs to simultaneously search. Take a very bit special care, because bidirectional search algorithm starts search at two ends. One from initial state called the forward search, and other from goal nodes called as backward search. To find the particular goal node, bidirectional search replaces one single search graph with two small subgraphs, in which one start the search from the initial vertex and other start from goal vertex. The search stops when these two graphs intersect each other. So basically bidirectional search algorithm run at the two ends, one from initial end and second one is backward direction. Second thing, bidirectional search can be use any type of searching algorithms like BFS, breadth first search, depth first search, and third one is depth limited search. You will see here inside this is our tree, and we are going to start by this location and we are going to start by this location. You will see here inside this we can find our goal state. If other find, if not found, then search is unsuccessful. Otherwise, if I found, search is successful and they are intersect at a one point. So it is very useful, but it is a very time consuming searching algorithm, because of it will use to take the searching algorithm in both direction. Okay. Now again I will go to discuss this is the difference between the iterative deeping search and the second one is depth limit search. You will see here in the previous example, if I want to find the goal state E, this is my goal state. This is my goal state, but I at the time of starting the searching, I have fixed limit of label is 1 at the time of starting the searching. I have fixed limit 1. There is no other way to increase the length. Why that reason I have found at only this label, but my goal state at the label 2. That's why I have not found. But for same problem, if I am going to use this iterative deeping search algorithm, definitely I comes to the goal state, because of at the first time I have mark our label at 0, then again 1, then again 2, at the label 2 finally I will find our goal state. This is the advantage of this type of searching algorithm. So in today's lecture we have already discussed about all type of uninformed search. Why we say uninformed search? Because they have no additional information about state and state space, search space. What are different kind of BFS? BFS use FIFO, DFS use stack data structure, last in first out. Then I have discussed depth limited search. Inside depth limited search, initially at the time of starting a search we finalize the limit. Fourth one is iterative deepening depth first search. Inside this search gradually we can increase the label of search, particular label of a search. And last I have discussed bidirectional search. Inside bidirectional search you will see here we start the searching from both ends. First is forward direction and second one inside the backward direction. Whether they find the particular goal state, search is finished and search is terminated. So entire through this I have discussed what are the different uninformed search algorithms are available inside AI. We will learn throughout our semester. BFS, DFS, depth limit search, iterative and bidirectional. In next lecture I will discuss most important and most useful searching algorithm, which is called informed search and heuristic search. Informed search and heuristic search. Here there is a many types of approaches are there. I will discuss in the next video lecture. Thank you so much.